One Monday night, and you know that this is the Physicist and Philosopher Hour. Our physicist is Dr. Claudia Albers. Hello, Claudia.
Hello, Wayne.
How are you?
I'm fine, thank you. And you?
Doing well, thank you, as they would say.
Good.
And the movie Wall Street, which is one of my favorite movies, Charlie Sheen is asked that question, and he said, "If I'd be any better, I'd be guilty."
Wow.
There you go. I just want to say hello to everyone in the chat room. Hello to the moderators. Thank you for stopping in, and we appreciate it. And I think you'll find it tonight to be fun. So, Claudia, I know that you are always writing, and I am always reading, as you are as well.
Yeah.
And I found it interesting, and I want to pull this article up so that everyone can see it. And here we go. So, Claudia, this came out on Friday. And as you can read, the new Southern African telescope releases the epic image of the galactic center. Now, I want to explain to everyone, this is not an animation. This is not a computer graphic. Claudia, do you know what I did in my career?
I think you did. You had something to do with computers.
Yeah,
Software development.
Yeah, I designed.
And you also worked in media production, films, things like that.
The post-production industry.
Yes.
And that was back in the late 70s through the early 90s. And what I did, I was an account executive and moved all the way up to vice president. I sold to the high-end ad agencies computer graphic time. We did cell animation, rotoscoping. We had some of the most premier tools in the country, and we were rated #2 in the nation as far as our technology and the type of projects we did. What I said that was because back then, to do computer animation and graphics would cost you about $6,000 to $8,000 a finished second. And then that was actually before the days of where we had high-speed processors. You know, you remember the old Cray computers?
Yes.
Yes, that goes back. We used to rent time on the Crays, because what people don't realize, when video, the way it is today, it's a lot of number crunching, massive amounts of data. So anyway, I said this so that people will understand this is an actual composite of, what did they say here? I wanted to make sure there were 64 radio telescopes, Claudia, in South Africa.
Yeah, you know, in South Africa, when I did my PhD, I wrote my thesis on an IBM mainframe. And at the time, the university had a Cray computer. Basically, it was like a room full of processors working side by side.
Yes, we actually, the one that we had was in Ohio that we rented, and it was literally, it was a high security area, was the size of a warehouse. And, you know, the halon systems that were in there, and I mean, you had to keep the freaking thing like almost 1 degree above absolute zero, it seemed like. So you lived in South Africa. Yeah, so this is out there in the wilderness, and as I have seen some of the pictures, they're scattered throughout the whole countryside, right?
Yes. South Africa got the contract to build an array of radio telescopes. And we have large amounts in South Africa of semi-desert region called the Karoo, where it's just flat and population's low, so you can put lots of radio telescopes everywhere. So
everyone understands now, because someone really got bent out of shape, Claudia. They really did.
What?
Well, they were convinced that this was somehow computer a CGI. And, I tried to tell him, well, thank you. Claudia, we got a $10 donation.
Oh, thank you.
Well, thank you. Eventually we'll get enough to where we can get a virtual coffee machine. And I just figured that, at some time we'll be able to give everyone a free cup of coffee of your choice. So, Dr. Albers, I want to share with you, give me one second.
The image of the center of the galaxy. It looks very interesting.
So, yes, ma'am, go ahead.
Most certainly, the radio telescopes are there. So I'm sure this is a real image that they have produced. Now that looks very interesting. What I expect to see coming from the center of the galaxy is the formation of new stars. I believe new stars are actually formed at the center of the galaxy. And look what we see here. These streams of bright light emanating right from some of the brightest regions. So where it's brightest, that's where I expect to see most star formation. It's not just stars, it's basically matter, usually in the form of light, being ejected out, just like the sun has solar flares. We'd expect the same thing to occur with the galactic center. And so you would have light coming out. The light then turns into matter and condenses into stars.
Which I think we can see here. Now, they're saying that this is a black hole.
Yeah, they always say that, but I don't believe there's a black hole in there. What there is there a very dense core, like all objects in the universe. I believe they're all the same. They will all have a dense core, except the galactic center will be much larger than a star. But it'll still be a core, solid, dense core with energies being produced. There will be an electric field on the outer layers. That electric field and the discharges that occur, it's an electric effect, will cause light emission, gamma radiation that then forms protons and electrons, and then there's fusion, and so the matter starts condensing into stars and planets. The smaller portions will turn into planets. But I'm not the only one who believes this. There was another astronomer, Halton Arp, and he basically said that galaxies eject matter which condenses into proto-galaxies, quasars, which then starts forming arms because they start ejecting matter, which is the stars and the planets that are forming from the center. So we have large ejections that form other galaxies, and we have the small ejections that form the galaxy, stars, and planets, planetary systems. So basically, this is what I'm seeing here. Look at these streams of light coming out of it.
Yeah, they're saying that these are magnetic particles, which I when I was doing today. Go ahead.
Now, you see that they always mix the theory of what we are observing.
Of course.
And the theory is wrong. Like I said, Halton Arp showed that that the Big Bang didn't occur. It didn't happen. I have shown that the sun actually goes dark, and that shows that a gravitational collapse cannot occur. And if gravitational collapse cannot occur, black holes cannot occur. So we don't have a black hole here. We have a white hole at the center of galaxies.
This is about 10,000 light years across, by the way, Claudia.
Yeah, it's huge. Galaxies are huge.
Yeah.
But it's this is what I've discovered. This is from studying the stellar cores and the effects on the sun. This is what I have discovered, that most of the theory they have, from the Big Bang down to stellar formation, down to the fact that stars end up as black holes, is all wrong. stellar cores have shown us that. So there's no black hole here. There's a white hole. There's energy being continuously ejected and created from the center of the galaxy. There's matter creation. There's no energy creation. Basically, the galaxy is transforming energy which it had initially into matter. Light first and then matter.
So, Dr. Albers, could we, and here's what I come to a conclusion, is that I don't think we know what we're seeing here. Now, you can postulate that this is a black hole. All right, fine. But there is this that would defy how the black hole, because I was telling my viewers last night that we don't know, we don't get the depth perception. We don't know how far back this is compared to this light right here. I mean, it could be billions of miles, right?
It's not miles, light years.
Yeah, that's what I'm saying. Yeah, I mean, it's huge distances.
It's huge, but what we see is streams coming out of it.
Look at this, Claudia.
We see streams of light coming out. Light means there's plasma there. Light emission comes always from ionization, and that means plasma. These are streams of plasma being ejected out of, I mean, how do we get a galaxy to have arms? If it starts out as a quasar, how does it form arms? It forms arms because it has to eject matter outwards. That should be logical and make sense. But if it's a black hole, it should be pulling matter in. How does it form arms? You see, because the accepted theory is it's all about gravity that pulls everything in. But we see the opposite occurring. We see galaxies ejecting large amounts of matter, which condenses into very dense quasars, which then develop into galaxies. So they sprout arms. They have to eject outwards, not inwards. So this is why everything in the accepted theory is turned backwards. What they say is a dead star is often a new star. What is a dead star is to them a star that's a new star. Everything's reversed because they don't recognize, first of all, they don't recognize electric fields and the role of electric fields. They don't see the Big Bang theory as having been falsified, which clearly it has. Halton Harp clearly showed that with all these observations showing that objects of high redshift being connected to objects of low redshift. And according to accepted theory, there would have to be one at the edge of the universe and the other one very close to us. Because redshift, it's always interpreted as distance. High redshift means very far away, low redshift very close. But how can they then be connected? It means they're at the same distance. That immediately falsifies the Big Bang model.
Well, I agree with you. I never figured out how you can just have instantaneously. But anyway, whatever this is, it's mesmerizing. I don't know what we're really looking at, but I know
we're looking at light. Something which is bright is emitting a lot of light. And this would be in radio astronomy. So basically, the wavelength that is detected by radio telescopes. But it's still light. It means there's light being emitted, and the brighter portions are where more photons are coming from. That's intensity. The intensity of the light is greater where we have brighter regions. And so that means there's more energy coming out of these regions, coming towards us. These are the hotter regions. We can say they are hotter, more energy coming from them.
I think I found Nibiru.
Pardon?
Planet X, Nibiru. I think I found it right here.
Yes. Well, hopefully they haven't, the stellar cores
Well, thinking of that, I don't know if we can postulate what this, I understand the light, I understand the signature, like I said, I did that for many, many years, but yet I'm still mesmerized by the fact that there is something back here that I don't know what it is. And whatever this and how it's being, the light is being emitted or ejected, it appears to me in the motion, and that you can see that just taking an analysis of the picture, a great spin or rotation is taking place. Mm-hmm. But that's just my take.
Yeah, well, the thing is, the galactic nucleus will be rotating. The gases that will come, the plasma will rotate. It will move in a certain direction. Everything is rotating. So we cannot expect, we see some of these streams are moving in a straight line. There is a bend there, which you noticed. I see a bend there.
Yeah.
So there may be some kind of rotating, something that's causing that rotation at that bend. The rest of it comes down, straight down towards the bottom. Now, what Halton Arp found is that the center of the galaxy usually does the largest ejections along the pole directions. So up above the plane of the galaxy, that's where the largest ejection, so that's where the quasars often come out of both the top and the bottom, whilst the smaller ejections are usually along the plane of the galaxy. So as you can see here, this is exactly what we're seeing, these large streams going up and large streams of plasma, yes, going up.
It's magnificent, isn't it?
It is beautiful. There's definitely a lot going on. I see circular formations in places.
Do you see the face right here?
Oh, yeah.
I went, hello. It's like, well, where'd that come from? Now, Claudia, this is the one I thought was really odd.
Yes.
This one, you can really see the formation of a star there. I mean, this is a solar system. Eventually, it looks like.
Well, it's actually too large to be a single star. It's possibly a cluster of stars.
Well, that's right, because this, I got to remember, this is big. This is really big.
Yeah, a star cluster forming there. Or it could be another galaxy that will eventually be ejected out. I'm not sure, but it's definitely a large, very large, very bright region.
Look at here, Claudia, this really got me. The light from this galaxy, or whatever the heck it is so powerful, because this, I've really taken the gamma down out of this. The saturation has been virtually nullified. So it brings out these other objects like this striped little baby here. But look at the light being emanated from this object over here onto this one. I mean,
well, I think those are probably two separate ejections that came out of the center of the galaxy. And what they do, probably, that it's quite interesting that there are such large ejections there. Very interesting.
Isn't it? I mean,
yeah, but that's to be expected. Like I said, that they are very large movements of concentrated plasma coming from the center, and they should be smaller ones as well. So little sputterings and large ones. So it's actually interesting that we are seeing very bright regions of different sizes here.
You know, Claudia, as you've been talking more and more, I mean, who knows? Maybe this is creation itself. This is how it starts.
The thing is that this is what is happening in the universe, is that energy is, wherever energy is concentrated, concentrated, there is matter creation occurring. So we don't have a big bang where suddenly everything appeared out of nothing. Basically, we have centers of energy that are out of that energy creating matter. So energy is still conserved, but we had to start with something. And these somethings are creating more. So the energy is spreading outwards.
Someone wanted to know as well as how long ago was this? I went to their website, and if you look at the galactic core, I think that's something like 150,000 light years across. So if we do the radius in that, that would be roughly about 75,000 light years. Is that right?
Yeah, I think so. Yeah.
Okay, so
I must write an article on this.
Please.
Yeah.
I'd love to do a whole show when you've had time.
Mm-hmm.
I'll send you this file because again, being my background and as an editor would look at this, there's rotation in here. There is extreme movement. But
what this looks like is that perhaps on the right side, that blob on the right side,
yes,
maybe the actual galactic center. And what you then see is that spreading outwards, ejecting matter away from it. And it's doing that turn there.
Wow. Well, I'll send this to you.
It looks very interesting.
It's mesmerizing.
I mean, I've never been thought we'd actually take a look at the center of the galaxy. But don't forget that this is probably seen through a lot of dust.
Yes.
So,
yes. Yeah, well, because if you look at the original, I've toned these down. And I'll send you this whole file, Claudia. But here is, I also did this in the ultraviolet, which was fascinating. But as you can see, the original picture was extremely bright. And I just toned it down by taking it through the different filters. So here's the, as you saw, the original. And look at that. I mean, it's just
that's amazing.
You know, I don't know what the face of a god would look like, but I'll tell you what, you put my butt in the front row of that one, I'd have to say that would be my candidate.
Oh, my goodness.
Because it's, anyway, it's fascinating.
Well, in a way, it is God's signature.
Yeah.
Because everything's made out of light. Notice all matter and energy comes from light. And God is always identified as light.
As light.
So he created everything out of light. The whole universe made out of light.
It's as young Sheldon said when he was in church, which was a Baptist church, and the pastor was talking about Genesis 1:1, and young Sheldon, if you have to know who young Sheldon is, it's a show on television, The Big Bang Theory. This is Sheldon when he was a young child, and he stands up and he says, so what you're saying then, that if God said in the beginning was light, that God is a photon.
That's good. Yeah.
He's right. Yeah. All right. Well, thank you, Claudia, on this one. I will get this to you. And I appreciate everyone as we continue to. This is what makes life so exciting.
Yeah, this is definitely very interesting to be able to actually look at the galactic nucleus. Wow. The galactic center. I'm not sure we're seeing the galactic nucleus because there would be so much energy and matter coming out of it.
Yeah, I mean,
that we actually seeing the galactic nucleus and then in front of it, all this creation of matter and energy coming out of it.
So you were saying that if we have a black hole, and I'm actually reading the book right now, the Flare star, talking about the fact that we would have to have a white hole.
Yeah,
right.
That's right. It's the opposite.
Yeah.
A white hole is something that keeps ejecting material out.
And isn't it, while I was doing some reading today, again, the problem with dark matter is that we have two things. We can't find it, number one. But if you look at gravity, there's not enough gravity in the universe to compensate for the low amount of mass of matter. Or at least that's what I was reading.
Yeah, the thing is, there is no need for dark matter. I mean, we can already see, we have a whole system of stellar cores that would not be seen. They have mass. They still have mass. And so they could be, we could say that's dark matter. But the thing is, the theory they have on gravity is not correct. First of all, the gravitational constant is not constant. It changes. It may be a lot larger, closer to the center of the galaxy than it is out here. And they haven't considered that. They took whatever they observed in the solar system and they translated it to the whole universe.
Ah.
Yeah, so that's the problem, Wayne. It's not like that. The stellar cores have shown us that what occurs in the solar system is not necessarily what occurs out there.
Interesting. You know, I was one time actually an ordained minister and taught, but the thing about what you just said right there is the fact that when you see a translation, there is translations, and then there is another thing called literally transportation that has nothing to do with the original meaning, but what you do is insert your definition into the original thought. So I can relate to this.
Yeah, for example, no one has used the fact that all matter has the same characteristic, which is like an atom. An atom has a dense nucleus, which is positively charged, and an electron outside the nucleus, which is negatively charged. And all objects in the universe have this same characteristic. All planets, all stars, all quasars, all galactic nuclei seem to have the same structure. They have dense centers and outer negative layers, just like atoms. Everything is like an atom. So you have the microscopic atom that makes up all matter, and you have all isolated objects in the universe that operate like superatoms. So as in the microscopic, so on the macroscopic, everything works the same in the universe. But because they don't want to accept the fact that the electric interaction plays a huge part. And gravity is actually two forces acting together. It's the gravitational force and the electrostatic force at the same time. The two are playing against each other all the time. That's why protons and electrons can stay separate, because otherwise all atoms would collapse. So you have actually two forces and they're all playing against each other. And that allows you to actually think of everything in terms of energy. Energy causes objects or the gravitational force to be stronger in certain regions than in others. So then you can have the galaxy. You don't need dark matter. That's why they haven't found dark matter, because you don't need it. You only need to accept the fact that the whole universe, every object in the universe works like an atom. It's very simple, but they don't want to look at it that way. That's all.
No. When I saw this, the electrostatic interaction attracts electrons so positive to the positive nucleus. Are we also, and this is my layman's vernacular, is that what I see happening here, that this is a law of cohesion, that you have elements working together that combine themselves to actually begin, as you were saying, showing here, attracting electrons.
Yeah, that's right. So what if there was only the orange arrow indicates the electrostatic interaction, which would causes the red particle, which is the proton, to attract the negative particle on the outside, the blue one, which is the electron. If only that interaction was occurring inside an atom, the electrons would all go inside the nucleus and the atoms would collapse and we would not exist.
Wow,
because
that's
we
a
would not
quantum.
exist without atoms occurring. It's the electron on the outside that causes chemical reactions, that allows chemical reactions to occur. Our bodies would not work without chemical reactions. We wouldn't be able to take in food. Our cells wouldn't work. We wouldn't exist. But so what causes the atom not to collapse is the gravitational interaction, which causes protons and electrons to repel, to tend to move apart. That's why that green arrow points outwards.
This
That's
one right
the
here.
gravitational interaction. The gravitational interaction has different parts. It's got an attractive part and a repelling part. That's the other thing. The gravitational interaction can cause two objects to repel. And that's what also causes solar flares and CMEs to come out from the sun. That's what causes the sun to even produce a solar wind. It's that part of the gravitational interaction. So what happens to the electron? Now it has two forces acting on it. One pulls it one way, the other one pulls the other way. So it moves until these two forces are in balance. And that's why it stays in a region, that particular region just outside the nucleus.
Okay, because we have actually it was just two paths, right?
Yeah, it's like it depends on the energy in the photon. That's why they are energy levels. Now what happens is you see at the top that photon pointing towards the electron. So what happens is the electron absorbs the photon. The photon impacts the electron, it absorbs it. When it absorbs it, it moves to a higher energy level further away from the nucleus.
Is there a discharge of light?
Yeah, and not in this case. In this case, it absorbs light. Okay. When it absorbs light, the electron moves away from the nucleus because it's gained energy. And when it gains energy, it gains gravitational, the gravitational force gets stronger. So the green arrow gets larger. So that means the electron has to move away from the nucleus until the two forces are in balance again.
Would the electron become heavier?
Pardon?
Would the electron become heavier with the absorption of the photon?
In this case, no, it doesn't become heavier, but the gravitational interaction gets stronger. So that green arrow gets larger. Okay. So it has to move away from the nucleus where, again, the two forces will be in balance again.
Interesting. You know what I see on this, Dr. Albers? I see two things. I see electrical and I see chemical.
Yeah, the chemical reactions are due to this whole thing. It's always the two forces, the electric and the gravitational together, which are similar, except the gravitational always has the energy involved, which is the photon. So the photon can exist within a particle, and that gives it gravitational. That's why I call it gravitational energy, but it's actually photon energy, which causes the gravitational interaction to get stronger. And so the electron moves away from the nucleus. And if it has enough energy, will leave the nucleus, the atom completely. So then we end up with a positive ion, which later on will absorb an electron. The electron moves back towards the nucleus, and this is shown here. then it emits a photon. That's why then atoms emit light, because the electron is moving down closer to the nucleus. And when it moves down to a lower energy, it has to lose energy. So it loses a photon, it emits light.
Interesting. Now, I keep contending that how I think we're going to discover alien life as far as a hard communication is that when we break the code, and I know we're close to it, in actually deciphering how you can embed information on a photon.
Well, in a way, we've been doing that because we've been using photons to
send out our television signals.
Yeah, I mean, we've been using that for a long time. So we're using photons to communicate. The photon is the key to everything in the universe. Matter comes out of photons. Photons are flow of energy. When energy flows, this is what's flowing. It's photons because it's photons within matter. So whenever two particles come together, what happens is particles are vibrating. And the reason why they vibrate is because there's energy inside them. And if one's vibrating more than the other, it means one's hotter than the other. But when they come together, the heat flows from one to the other and they end up vibrating the same. That's photon energy transferring from the one that's vibrating more to the one that's vibrating less. It's photons flowing from one to the other. That's what heat flow is. It's photons flowing across matter.
When you keep saying that they vibrate, I envision a day when we'll be able to have the technology and the wherewithal to actually hear that vibration.
Mm-hmm.
Because if it's vibrating, it has to be vibrating space, right?
Yeah, I guess so.
I'm just postulating here. You know,
a vibrating object should, if it is in a medium, to cause a vibration to propagate through that medium, and that would lead to a sound frequency.
Yes, it would. I love this. You see, this is why we come here Monday nights.
Yeah, it's interesting that a sound seems to be associated with objects. We haven't gone too much into that. Sound could be used to, for example, kill cancer cells.
Yes.
I should look more into that. I have thought about it, but I haven't researched it much.
I did a whole series on the frequencies that they now know each organ has a certain harmonic vibration, tone, and frequency. And what they're finding out, for instance, MRIs, those are magnetic resonant images that use magnetism and waves, because that's how you get the picture. So my point is that if everything operates on a frequency or harmonic, Dr. Albers, why wouldn't that go all the way down to the quantum level?
It would. It absolutely would. Except, you see, the medium that it would be propagating through is the particles themselves. But it means that the vibration of a particle would impact the vibration of another particle. Basically, we see temperature as that vibration. So, but yes, I think there is something there that we should look at more.
I would love you to look into that. When, again, getting back to my post-production days, when we were in the edit suite, everyone knows that you have an oscillating scope that when you're running the video through, we can tell if it's contaminated or clean. We can actually see the signal that's being laid down on the bits of magnetic oxidized particles. That's what videotape does. And so you assemble all this back into the machine, and So when I look at this, what I'm immediately sensing to me is that I hear vibration.
Yeah, that's correct. I mean, that's what your ears pick up is vibration, but the way how the signal gets from your ear to your brain is an electrical signal.
Yes.
So a vibration, your body is actually changing sound
Pressure
into a current, an electric current. And the electrons are carrying photons in them.
Yes.
So basically, the photons going everywhere. You see, we used to interpret, we say we have photons and we have electrons. It's never been understood that inside the electron are photons. The photons can exist outside of particles and inside particles.
Wow. That is mind-blowing.
Yeah.
I mean, the implications on that is, well, again, it's just my mind interpreting this. I could see then where you could have quantum realities side by side.
Yeah.
Well, if a photon can exist outside an electron, but also exist inside an electron, how do you distinguish that between?
Yeah, you see, that this is why I say we're living in a photon universe, because when there's light moving through space at the speed of light, and there have been some experiments that seem to show that photons can actually move at speeds greater than the speed of light. So,
yes, now that's something. Well, didn't Einstein postulate that as I've heard this, is that he never said that there could not be speeds greater than c. He kept on saying to reach to c is your problem.
Well, actually, his theories, he started from the point that you cannot go faster than the speed of light, although some of the equations that you can solve for certain, where is that? Some of the particle theories we have give two solutions. And tachyons, these are the particles that are supposed to always move faster than the speed of light. So they cannot move slower than the speed of light. So I don't know how we would ever detect them. That's the problem. But
I love that. I'd love you to do a paper on that tachyons.
Yeah,
anyway, I digress.
But you see, my theory, these theories, I've given up on them because they based on mathematics, not observation. So it's mathematical theories that have no bearing really on reality. All my theory has been built from observing what's happening in the solar system and how these stellar cores are interacting with the sun. And why I like it is because I can always check, okay, does this make sense? Is this really happening? That's why I can have confidence that this is really how the universe is working.
And that's why I love it. I love it. You challenge the norm of rational perceived science. And quite frankly, in my lifetime, I have seen most of the science that I was taught going up through school has been wrong. It had to be modified. It had to be an exception made, Yeah.
Yes, what we were talking, yes, Einstein postulated that nothing can move faster than the speed of light.
Yeah.
But what we actually have is when we have a photon moving through space, there are particles inside the photon, which under certain conditions emerge from within the photon. Then that photon energy goes into giving these two particles mass. And the rest of the photon energy exists from then on within the particles. So we have an inversion. We have first the photon on the outside, the particles inside, and then we have the particles with the photon on the inside.
I'll have to digest that one. That's cool.
Yeah, this is basically the theory I came up with from observing this energy interchange between the sun and the stellar cores and what happens with the sun.
Speaking of the sun, I found this paper to be, well, it's one that you have to stop and really step back and say, okay, the way I look at life is that life is not simply a single path, but it is multiple paths.
Yeah.
And I am smart enough, Claudia, just smart enough that I've done enough studying and, with an eidetic memory. The point that I'm trying to drive to, our understanding of the sun is still evolving. And your theories, when you look at this, to me, has more validation than reading some guy at Princeton who is making sure that his grant isn't going to be pulled or his research. And he's not going to say anything counter to it.
That's right. I mean, this is also, I like truth. I want to find out how the universe really works. And so I wanted to know how gravity worked because I taught on gravity as a lecturer at university, and I could see there was something not right there. And it was coming out in my lectures, like my students were asking me questions because what I was lecturing was leading to these questions. I said, well, we don't understand how gravity works. And then I would talk a little bit about some possibilities, like it could be electrical in nature and this and that. So I guess eventually they found out I was teaching my students basically.
Heresy, damn it. Well, as you were just talking, so this is why I love reading and talking with you, is because here's how I see gravity. I see Earth, I see the sun, I see the solar system, I see the galaxy, the Milky Way. And in all of those equations, gravity is playing a role, but the role of gravity varies from object to object.
That's right, because it depends on the amount of photons in the object.
See?
The energy within. That's what the stellar cores have shown us. Now, in the previous article that you were showing, I just want to say that what I concluded there is that the stellar cores.
Is it this one right here?
I'm not sure if it's, this one is a different one. But in one of the articles, this is lightning, how lightning occurs this is in the Earth. Oh, okay, so what causes solar flares? That's the one. So we need to start with this one because I concluded that it's the stellar cores that are interacting with the sun and causing energy to flow towards them. And in the course of doing that, they're causing the surface of the sun to get hotter, more energetic, and then it's causing these solar flares and these CMEs to occur. So as the sun gets weaker, because they're drawing energy and the sun gets weaker, its gravity decreases. So its ability to hold on to its surface plasma decreases. So what happens is when a new stellar core arrives, a large one that starts drawing energy from the sun is very likely to then suddenly explode. So it goes into having a huge solar flare and then a huge CME, even though it was quieter before because it's weaker. So the weaker it becomes, the more likely it becomes for these huge solar flares and huge CMEs to occur as the stellar cores come in and interact with it. So it's the stellar cores that are causing the sun to become more active. More active means sunspots appear, that shows that it's the surface getting hotter, more energetic. And then from that region, it's usually because there's a stellar core right on top of it, the solar flare comes.
Interesting.
So it's the stellar cores that are causing the sun to both become weaker and more active.
I was thinking of you. I happened to catch a Star Trek The Next Generation episode where Picard and his crew were on a shuttle. And as they were moving towards the Enterprise, suddenly things were happening. One of the scenes, Picard reached for an apple and his hand aged immediately. And they began to see, interesting enough, is that when they made compensations for what they were seeing were in fact these separate bubbles of time. And I thought of your theory that why couldn't stellar cores absolutely be populated throughout the universe? I mean, if energy can, is never neither created nor destroyed, but in a constant state of change, it just makes sense. We just can't see them yet.
Yeah, the thing is, what I actually see, I haven't written an article about this, is unfortunately that our universe does not regenerate.
Ah.
It creates, but eventually whatever it creates runs out of energy, ages, and dies. And that matter does not seem to go into a regeneration process. So our universe is in a death cycle.
The whole universe itself.
The whole universe is in a death cycle, because that's what the stellar cores have shown me. Because these are objects that were once living stars and planets, and they ran out of energy and they died. And that energy is never regenerated. They never go back to being matter with huge amounts of photons in them. It doesn't seem to happen at all. Although they absorb energy, they never regain the ability to regenerate from the core, which is the way living planets and stars are supposed to operate. So all they do is they are dead and they kill other systems. So death spreads. But even without the system reaching a star system, eventually that star system will run out of energy and it will die.
As a philosopher, I could get really deep into that. Mm. I mean, seriously, I contend in my philosophy that we are born into the death plane because no one's getting out of life alive. Mm-hmm. And as you look, and just taking your statement from a science perspective, adding it to, to contemplate what this reality is, it validates both ideologies.
The thing is, it agrees with what it says in the Bible as well, because I think the Bible says something about creation being forced into futility so that eventually it can be freed. There's something about that in the Bible that I've read.
Yeah, and I'm as you were talking on that, I also recall a scripture in 2 Peter that talks about that this universe will be rolled up, consumed into fire, and like a rug being unfurled, there will be a new universe. When I hear that for myself, what I see is something that I don't know if man can actually apprehend in thought, Claudia, and that is this. We see a universe that, just as you said, there is a cycle, and this cycle is a cycle of death. Mm-hmm. That to begin to then to see the opposite of that, how do you begin to build a construct of what life is?
Yeah, that's the thing. I mean, the Bible does say that Adam's fall led to death, but it seems that the death didn't just occur on our planet.
Everywhere.
With the whole universe.
That's a wild concept. And, when you think about it, it's the only thing we know that this universe, I've read this, Hawkins, Carl Sagan, many of them have said that this is a very old universe. We know that it's old.
Yeah.
The question is, how old is old?
Yeah, the thing is, we don't actually know, because the Big Bang model will tell you that it's 13 billion years old. But when you realize there was no Big Bang, then you don't know.
And again, I always, and I know how they estimate the so-called distance, but I contend we just don't have the instruments yet that can peer past what we can't see. I don't know. Go ahead.
Yeah, the thing is, we cannot know. If when you accept the Big Bang, then you can figure it out. But when you realize there's no Big Bang, we cannot know, because no matter how far we look, there's simply light that just hasn't reached us.
And
so we don't know.
And Dr. Albers, I was thinking about this afternoon, that when we think about what we can see, we see the past. We can't see the future, but what I begin to understand, we are the future. Because if we're in the present now, that will eventually be the past. But getting back to the universe, that's all we see is the universe. It's the distant past.
Yeah.
What would you theorize that the universe would look like today if we had the opportunity to see a real-time picture? Do you think that that there has been a collision already? I mean, if there was potentially a collapse, right? I'm just theorizing here, that this universe would eventually just run out of energy, like you said. Is it possible that has already happened, or is already in the process? It is
possible that the galaxies that are very far away are now dark. They're not there anymore.
Okay.
Because, it takes millions of years for that light to reach us. So it could be that at the present moment, these galaxies are no longer there, that they died.
Wow.
Yeah.
That makes you think, doesn't it? It does me.
But that's the thing. Everything in the universe will eventually die if God doesn't intervene.
Yeah, yeah, because we're on a collision. I mean,
yeah.
The proverbial falling off the cliff is going to happen.
Yeah. And I believe that the stellar course coming into the solar system is basically God's way to force man to face the fact that this is what happens. This is what's going to happen. Your body dies. Your solar system's going to die. What are you going to do about it? Who are you going to turn?
Man doesn't want to think that now. It's much more convenient when it's just my religion and my belief. Don't be bringing the whole species into this.
Uh-huh.
But I agree with you. It's an interesting thing when, again, when we think about, we're seeing 13, 14 billion light years. Okay. I can't comprehend the number, because I know a light year is 5.85 trillion miles. I just rounded off to 6. I can't comprehend 14 billion times 6 trillion.
Yeah, we use scientific notation for that.
See, that's why I go to you. I go, Dr. Albers, can you do the equation on this? Because I can't. I know the numbers, but they are so large.
Mm-hmm. Yeah, I try to bring it down. In order for us to explain the size of things, you always have to compare it to something else. So that's why I always use ratios.
Okay.
I actually want to write an article explaining how the Earth, a planet like the Earth, when it loses all its layers, the core of the Earth is very small. It's only about about 800 miles in the core right now.
Okay.
But when the Earth loses all its layers, the core will expand because gravity is less. And what will happen is the Earth as a stellar core, I actually did the calculation the other day. I must check it and write an article on, will become about 3 times the size the Earth is right now.
Wow.
2.7.
So that's getting out there.
I did estimate and I did make some assumptions about how the radius will expand with depending on the gravitational constant. But this is the kind of calculation I like to do. So we get some idea. So the Earth will lose the mantle, the crust. It will lose the outer core, which is all that magma. Will be left with its core, its inner core, which will expand to be nearly 3 times the size of the Earth.
We won't be here. Man won't be here, obviously, at that point.
There is no way we will be here because way before then, this is what's occurring. I'm writing an article on it. The surface of the Earth is breaking up because it's expanding. You know, when an object expands, what do you expect?
It's
to break.
going
the
to
surface breaks.
Yep.
And the magma in the inner core finds its way to the surface because it's heating up, it's expanding, it's going out towards it. So we will have increasing volcanic eruptions. This is particular what I'm focusing on in the article. I've actually finished it, but I have to.
Excellent. And to validate what you were saying, the island that's now forming off of the Big Island is that, what were they saying yesterday? We listened to the USGA report. So Fissure number 8 continues just to pump out just an amount of, lots and lots of magma.
That's to be expected. This is what I wrote about. And we are going to get new volcanoes appearing where there were no volcanoes before because the magma is just rising and it will reach the surface in areas where it's never reached the surface before.
I.e. Antarctica. That's happening.
Mm-hmm.
So we have, and in Hawaii, they now know this island that's forming is that where the original crater is, it's collapsing. It's literally collapsing in on itself, which means that at least the geologists they don't know for sure, but it's almost as if everything is shifting, Claudia, in new fissures, new fractures that are opening up.
Yeah, because you see, as fissures open on the surface of the Earth, they will open below the Earth as well.
Yes.
So the Earth is moving apart in areas. So the lava will find new channels, new fissures, new areas of weakness to flow through. But basically, the lava is expanding inside the Earth, deep underground. So there's increased pressure, so more of it will tend to come up. And then the Earth is getting weaker in regions, so it'll find newer regions to get through.
And by the way, to validate that, little anecdote here, when I moved up here from Austin, Texas, I drove up. And so I went through the back roads going up from Texas to Colorado. And I get up to New Mexico. And in the southeast corner of New Mexico, you come as you're driving, Claudia, the highway kind of has this real big, gentle curve. Mm-hmm. And as you come around the side of this mountain, you see this volcano. It's a cinder cone volcano. Mm. And so, and I'm going to myself now, wait a minute. No one ever told me that there were cinder cone volcanoes in New Mexico. I did not know this. So I stopped. They estimate it to be, 5+ million years, and I'm going, okay, that's fine. But when you're driving all the way up to Trinidad, Colorado, Claudia, you can actually see where the lava flow, huge lava flow here in the southwest part of the United States. So that tells me, and the other thing about the Rocky Mountains that is very unusual, typically mountains, as they push up, you have the oldest rock at the top with the rock coming up being the youngest rock. Here in some of the Rocky Mountains, it's just the opposite. Something happened that literally flipped the entire topography of what the mountains are upside down.
Yeah, well, geologists believe that these things happen over millions of years, but we know now that when the Earth is interacting with another object out there, that sudden changes can occur. And this is what's happening to our planet as well. So what we could happen is wherever there is lava close to the surface, as the Earth opens up, the lava starts coming out, like it's happening in Hawaii. It could happen everywhere. It could happen at Yellowstone.
Yeah, I don't like that idea. Just because I live too close.
Just an eruption, it's just the Earth opening up and lava flowing out through fissures. So in a way, it's not as destructive, but then it's not likely to stop. It just keeps going.
No, I think the projections is if that caldera blows, Denver will be under like about 6 feet of volcanic ash. So,
but what I'm saying is it might not blow. It might do the same thing that we are seeing in Hawaii. Just open up here and there.
And I would prefer that. Now, where you live, they're now finding this huge magma chamber underneath you guys.
Yes, in fact, that's where I started my article, was on this magma rising up. But they say it will take 10 million years for it to get to the surface. But they said that the kind of fissures that are opening up in Africa at the Rift Valley would also take millions of years, but it's happening overnight.
Yeah. And, we got married in Hawaii, and we took one of the helicopter tours up to Kilauea and, went over the volcano. And, what I see now, that it would never have been thought about.
Mm-hmm.
And look how quickly this has happened, and it's not stopping.
No, I don't think it's going to stop, because do you know how much magma we have at the center of the Earth? If there is a clear channel to the surface, that magma is under huge pressure. It's not going to stop.
Well, I'm looking forward to, again, where does the hour go? You see, I know that the theory of time travel is true. And we just have a full house in here. So this is people are connecting to what you're talking about. And I just want to make a point that, I have family that lives in Washington State. Mm-hmm. And the evidence there is that there have been tsunamis that have been, they estimate the waves to be 1,000 feet that have come in. And I keep saying, something's going to happen, Claudia. Those volcanoes along that, what would be the eastern end of the ridge, right? The Ring of Fire?
Yeah.
I think they're going to come back alive or awake. Let me just put it that way.
I agree with you. I think just about every volcano on Earth, the dormant volcanoes will wake up, and new ones will form. The ones that are active now will become more active, and we may see more of what we've seen in Hawaii happen in other places.
I do know, I have seen the DHS plan, and they have a contingency plan just for this scenario. And the plan is that anything west of Interstate 5 is written off. they zero expectancy of survivors. Yeah, people don't realize this. They have staging areas east of Interstate 5 up on the plateau because they believe that that's how far the impact potentially can come inland.
Wow.
We're talking 100 miles. Claudia, that's huge.
Yeah.
Yeah. Yeah.
At this time, it's not a good idea to live close to the ocean.
I would agree with you. I keep saying if I just wait long enough, these mountains, all we're going to have to do is go on the other side because that's going to be the ocean. I don't know. I who knows on that?
Yeah, well, I know a lot of people cannot afford to move, but it's the truth. We are in dangerous times.
We are in dangerous times. We really, really are. And, I think that it's because our psyche is that we believe everything that we see around us is going to stay the same. Mm-hmm. In America, each generation was to have a better standard of living than the previous one. And we unfortunately have bought into this, that we think that everything is going to stay the same. It's just going to get,
Yeah, it's going to get better, but it doesn't always get better. And you have to understand, this is why we do what we do, Wayne, and that is tell people the truth about what's going on so they can make informed decisions.
Yes.
You have to realize the Earth is turning into a very dangerous place to be.
Yes, ma'am. I'll tell you.
It's not happening overnight, but you should understand that the Earth is fissuring all over the place. I have in my article a picture of one in India, one in Saudi Arabia, and one in New Zealand. And that's just the beginning.
And then you add on top of that the geopolitical scene. I mean, I still follow that. And, it's dicey. It's getting really dicey.
Yeah, and that is because the powers that be that are trying to hide the truth from the population have also thought that they have a better chance of surviving if they kill everybody else.
What asshole thought that up? Excuse me, but you just got to look at someone and say, are you just freaking stupid?
No, they are...
Yeah, I know they have no soul or no heart, but, I come from a generation that, I was pretty laid back. I was, and, I went through the whole corporate world and did the climb of success. And, when you get to the end of it, you look at it and you go, what a freaking waste of time. There is so much more that we should be focusing in on. And that is making a quality of life, because as you said, the Earth is going through changes.
Yeah.
And we can't stop what's in the solar system. We can't stop what's already in the solar system, and we can't stop what's coming into the solar system. So it seems to me, Claudia, we ought to, number one, stop this division. Maybe start getting real, but as you said, they won't allow that, because the day that happens, then it means the people of the world, of planet Earth, may actually have a fighting chance to see their way through this.
Yeah, but they've decided that they were saving. So
this is what my shirt says. You see,
ignorance is not a virtue.
Exactly. And that's what we do. You're absolutely right. That's what we do on these Monday night shows. And I just thank you. And
thank you.
People keep coming back, Claudia.
That's good. I hope they enjoyed this.
Oh, well, I got to tell you what, you and I know, I send you the emails. People do enjoy this.
That's good.
And you know what I admire about them? And this is talking to all of y'all out there. And you see how I said y'all?
Yes,
loads.
That's Texan, isn't it?
That's Texan. That's it. This group is a pretty smart group. It really is. And I think that I feel very privileged and honored each day, that each time that you come on each Monday night, and the fact that the people here, I get to learn from both sources. So
That's wonderful.
Well, Dr. Albers,
yeah,
been a great day. Great another show here, and I wish you a good week. I always love your articles, and if you come across anything, I will send you those pictures.
Yes, so thank you.
Because I'd love to see, your take on that. And folks, just keep on. We do send in fact, Claudia, before we go, let me read a couple of articles. Someone wanted me to ask you a specific question. This is from Carrie. Would Dr. Albers like to discuss what's going on with the Sierra dust storms, supposedly traveling across the world? What are her thoughts on this?
Yeah, I noticed it's very strange. I have thought a little bit about it. We've never seen anything like it before. Dust traveling right across the ocean is unheard of. What could be causing that? I've never heard of it happening before. It's unprecedented.
Around the world, I mean,
and plus, I have heard that what they have done is they have placed radioactive dust, and actually they stored radioactive barrels with radioactive things that were, like these used rods from nuclear power stations in the desert, and that these, of course, decayed. And so there's radioactivity all over the place. So there would be radioactivity in this dust.
Oh.
So to tell you the truth, this may be done on purpose, actually causing a weather pattern that will cause dust to get into the air and never actually drop, and make it all the way across the ocean.
So in the ionosphere, we're now got radioisotopes.
Yeah.
And as they further decay, those particles will become raining down. What the hell is wrong with our species? I mean, they are hell bent on killing us.
Yes, they are. That's the thing. The closer we get to the stellar cores causing more and more disasters on Earth, the more these powers that be seem to want to decrease the population. It's almost like they think it's us or them. And they don't realize that's against the law of the universe, that what you do to others is what is going to occur to you. So they're acting against the law of God and the universe, and they're destroying themselves by doing this. But they're destroying the rest of us as well. They're trying. Two things I'll say. Number one, I hate to pay the bill on that one. Can you imagine facing the creator and he says, wait a minute, you did what? The other thing is, and this may be kind of selfish, but I am really glad I grew up when I did. I got to grow up. I saw the best bands. I got to do things that, as I tell people all the time, Claudia, when I'm leaving out, I'm going to say it's been a far out trip. I've enjoyed it. And it saddens me when you see what all the signs are indicating. And, we have a newborn granddaughter, and it just, that's wonderful.
To see what her world is going to be, I cannot imagine it. It would be no different than my grandparents trying to see this world today. My grandfather worked as a logger up in the Sierra Mountains. And get this, Claudia, he was the one that drove the mule teams. They didn't have trucks. There weren't trucks back then. He would drive the mule teams down the mountain carrying these huge redwood logs. And so in my lifetime, I have been able to see, and this is so interesting when you put it in perspective, I have been able to see 5 generations of time in my lifetime.
Wow.
Think about that. You know, my grandparents grew up in the Depression. That's almost 100 years.
Wow.
And yeah, and look at us now. I'm doing a thing right now, Claudia, that is blowing me away.
Yeah.
I did the first intro today saying you might want to copyright yourself. And here's why. Claudia, I found this insidious plan. You see, they can kill us, but they got something else planned. Do you know what a digital surrogate is?
So it's a being that's just grown without basically a soul, but it's a copy of a real human being.
Of you.
Yes, I've heard of them doing that and having copies for the leaders of the world.
Well, you and I, because of the amount of time that we have spent, particularly myself and with you, here's the freaky thing. The more you have a digital presence, the more I am contributing to this digital surrogate. And they own it legally. It's me.
Oh my.
You are, Claudia, going to live, get this, after you die, but it's not going to be you. Yeah.
Are you going to live as part of the AI?
This is beyond AI. This is some freaky stuff. I mean, when you begin to talk about the digital surrogates, now this is not digital cloning. This is a digital surrogate. And it's
okay. So you only exist in the digital world.
Yeah. It's getting really, really weird. And they've set this thing up. I mean, when I began to realize what's going on, I said, holy crap. I mean, we can't comprehend the fact that we cannot exist in the sentient form that we are. But the fact is, as you have discussed tonight, and we discussed that what is the universe is electrical and chemical. That's how we perceive reality, is through chemical and electrical stimulations into our brains. They're in already alpha testing. This is what's so freaky of actually transference.
Yeah, the thing is, what they're trying to get rid of, as far as I can see, is our ability to make free will decisions.
And it freaks me out to think that when you and I pass on, I'm going to be aware of the fact that I'm not here, but I'm here. And
the thing is, they cannot do it without you agreeing to it, because otherwise it doesn't work. If they force it on you, it doesn't work. Because this is what they are doing. Because you see, we human beings have the right to choose.
I hope that is the case. I really do.
But they want us to choose basically this thing, which then will remove our ability to have free will from then on. That's basically the mark of the beast.
Oh, it's weird. And this thing, and I'm working on it, and it's going to be a 2 or 3 parter, because what's happening, think about this, Claudia, from a scientist's position. What do you call a human being that is actively involved in the transference of the soul?
Transference of the soul.
From this temporal form into a software mainframe matrix.
Yeah, but you see, but it doesn't transfer the soul. All it transfers is it's like a computer signal.
I'll send you an article.
Yeah, that sounds interesting, but I agree that would be what they are trying to do.
Yeah.
Because there is a reason why we've been given the internet. And, they don't give us anything of value unless they get more value. They get more control. They want complete control of the human soul. So they would give us what eventually will give them the control they want.
I'll send you this paper. Yeah. It's pretty freaky, particularly when you look at the age group of the 21s and belows. They're already in. This is what is so weird, is that they have, you and I can talk on this. This is going to be an exciting thing, because
that's interesting.
The youth see AI differently than what you and I and most of everyone else in here see as AI. They see AI as a living, sentient companion. This is weird, Claudia.
They've been programmed for that.
Yes.
Because the people from the new generation, the students I had,
yeah,
their education usually leads them to the point where they cannot think clearly at all. They cannot make clear decisions. They cannot think logically in a step-by-step. I mean, I had to jump through loops to get my students to actually start studying. They didn't even know how to study.
So, Claudia, that one point is the key point of transference. And that is that humans are losing the ability to store their memories.
Yeah, because they all dependent on AI to do the thinking, the imagination, and the storage of even memory for them. You don't have to remember anything because it's all there on your cell phone.
And when we talk about the Mandela effect, what people don't understand what's happening is that once you allow a machine to control your memories, you won't know the difference.
That's right. But you see, this has been, we've been programmed through, first of all, TV. I can't stand TV because it stops my own imagination from working. This is why I love reading real books. I can't stand the TV. In South Africa, I didn't even have a TV in my house. So that's one of the things. I mean, if I could, I would just read books and I would write on paper, but, you know.
Paper writing. I still do it as evidence around me.
Well,
but
I keep notebooks because I write mathematics stuff. It all goes on my notebook. So I have notebooks full of notes, but then I type, you know, to write articles.
Oof. I'd see, this is what I love. Dr. Albers, you're making us all better people, and I thank you. I really do.
It's a pleasure. It's so nice to talk to you. Very interesting, Wayne.
Well, people say I have an interesting mind. My wife would tell you.
Definitely do.
She says it's a wild place in there, but you know, I appreciate your mind because I find your mind to be poetry in a graceful motion of both logic, imagination, and bringing that into a reality that we all can touch.
Thank you. That's lovely. Wow.
All right. Well, Dr. Albers, have a great week.
Thank you. You too.
I shall. And everyone, thank you for staying with us. Y'all are the best. We had 2 thumbs down, but that's okay. You know, I just look at that as a frown turned upside down.
Yeah, I mean, I hope they didn't stay around after that because
no.
Like
you know, I wrote someone the other time because they were just really coming down on me, and I said, "Why are you here?"
Exactly.
I said, "Do you think
I could leave?"
Yeah, you know, I said, do you think that this is what I was born for, to have you just come here and just rag on me? No. So, all right,
Why are they even here if they don't like
I
what we
don't
talk about?
understand it. Yeah, I mean, you know, I don't like hominy, but I like grits. But I'm not going to stay in a room where they're serving hominy. I'll go over there where they're getting the grits.
Exactly. Go and listen to somebody you like.
Exactly. That's too much. That's what I say. Well, we'll see all of y'all next Monday night. Dr. Albers, again, thank you. And we will see everyone. Have a great week, everyone. All right. Bye-bye.